Hey everyone, we've been talking about the MSP430, its hardware and software, and this video is going to cover some of the extra little goodies that are packaged on the LaunchPad in addition to the microcontroller. This is just an overview to give you an introduction. Some of this won't make a lot of sense, admittedly, until we start programming it in assembly, but pedagogically, I think it makes sense to introduce these topics now before we start with the assembly. So maybe the most important one of these goodies is the onboard emulator at the top left of the board when oriented this way. The onboard emulator communicates with a personal computer running Code Composer Studio for programming and debugging. And Code Composer Studio is something that we're going to look at in this class. You'll use it a lot in lab especially. Below that is the reset button. When pressed, the microcontroller is forced to reset and runs the program from the beginning. In the middle of the board, at both left and right, are the connectors for the booster pack, which expands the board's functionality. The board also features an LCD display, and below that are two LEDs and two push buttons. The board features crystal oscillators and a 1 megahertz main clock that synchronizes activity. The clock frequency can be programmatically configured to whatever you want, within reason. Not too high, I guess, lower. In a previous video, we had said that the MSP430 had 20 memory address lines, but I said that at that time there was a caveat to that. Some of those addresses are internally used by the board, and only 65,536 addresses are available to us. That's 2 to the 16th, or 64 kilobytes. These are the addresses 0 through FFFF, 16 memory address lines, 2 to the 16th. Additionally, the board is loaded with general purpose I/O and digital I/O, serial communications, timers, an LCD controller, and there are a lot more goodies. So please note, though, that the digital I/O, which we will need early on, they're labeled as P, capital P, X, where X is an integer beginning at 1. So, for example, capital P, P1 refers to the first port, P2 the second. Also note that the ports are multi-bits wide. The exact number depends on the port. So individual port bits can be accessed using a period or a dot operator. So for example, the 0th bit of the first port is labeled as P1.0. Again, that P must be capitalized. The top figure in this image to the right illustrates this idea of labeling the ports and the individual bits. So PX dot something, PX dot 0, PX dot 1. If you're dealing with port 1, port 1.0, port 1.1, and so forth. Additionally, the port registers have specific labels, as you can see in the bottom right figure. So for example, the direction of port 1, whether you want it to be input or output, can be set by referencing P1 dir. So the X, again, is an integer there that indicates the port. Now, it would be impractical to have a dedicated pin for each and every peripheral signal, as too many pins would be needed on the package, right? So simultaneously, not all applications require every peripheral signal at that same time. So to reduce cost, multiple internal peripheral signals are assigned to the same pin, and then the user configures the pin to be used as whichever peripheral is desired. This approach, yes, limits some functionality because it's possible that two peripheral signals may be assigned to the same package pin internally, but are both needed by the user. So in this case, the user would need to select a different microcontroller. The device also features 5 independent timers whose clock frequencies can be selected from several onboard clocks or divided down. As we said earlier, the LaunchPad contains 2 independent general-purpose LEDs, one of which is red and the other green. The red LED is written as LED1 on the board and in the documentation. The green LED is written as LED2. This labeling here can be seen on the schematic. Notice above the LEDs, which are the triangle-looking things to the right of the figure, the labels red LED1 and green LED2. LED1 may be accessed by the 0th bit of the first port, that is, port P1.0. LED2 may be accessed by the 7th bit of the 9th port, or port P9.7. Again, this information and schematic is from the LaunchPad User's Guide available at Texas Instruments website, right? Page 31 there. So you can click that link. The link is too long to place on this slide. Sorry. Also from the user, sorry about that. It's also from the user's guide. The 2 push buttons, S1 and S2, are both at port 1, with one button being the first bit and the second being the second bit. That is port bits P1.1 and P1.2, respectively. The switches are labeled on the device as S1 and S2. Their respective port bits are also labeled on the device. And again, this schematic that you're looking at right now, that comes from the user's guide. Okay, so that's enough with the LaunchPad, and I think that's enough for the MSP430 before we start taking a look at programming it, all right, getting our hands dirty. So next time, we're going to start to apply all of this to program the microcontroller in assembly language. A good place to start is with a Blink program, so I will see you then. Thank you.